Hello everyone, thanks for your coming. Today we are discussing how to scale our Edge AI with Wise Edge and Edge Impulse. It's an exciting era that we bring the intelligence to the edge. However, it's not so easy to make it happen from POC to scaling. We face lots of challenges, not only for small developers, but also for enterprises. Today, we are focusing on how to scale up these challenges, how to really implement the intelligence at the edge in the real world. So I'm thrilled to have Richard, my colleague, who is the chief architect of Advantech. And also we have some exciting recording from Zach Shelby, the CEO of Edge Impulse, who is also our firm partners. We'll discuss how to bring the edge intelligence to the real life. Hi, Richard.
Hi, how are you, Hank?
So, could you please set the backstage about how Wise Edge, the purpose of Wise Edge, and what is the purpose and how to make the edge intelligence to real?
Okay, maybe we can move to the next slide. Okay, I will use this slide to elaborate what is Wise Edge. In the past, most of the industrial software, such as most industrial software, such as the SCADA system or traditional IoT softwares, they focused on data collecting and pre-process, but not so much on data analysis. But to fulfill the Edge AI requirements nowadays, we know about 3 years ago, everybody talked about AI because of ChatGPT. So we design a new structure, or you can say the new software for industrial use, the Wise Edge architecture, since last year. We can divide them in 3 different levels. The third level is, I believe most of you are familiar with. They are traditional industrial software, such as we have IEMS. For Advantech, we have IEMS for energy management, or the IoT suite for data collecting and analysis. And the level 1 and level 2 are the new layers that we give for our developers, or you can say for our customers. But now we move our customers from the traditional end users to expand to developers and individual developers and system integrators. So at level 1 and level 2 will provide a lot of tools and APIs for further development for Edge AI specific domain applications.
Awesome. So which means that our Wise Edge is a technology platform in different layers, providing the tools to help the developers or IoT users to build up their application and set up their intelligent device ability, right?
Yeah, exactly.
Okay, so I asked Zach, CEO of Edge Impulse, the same question during our online conversation. I asked one very interesting question to him, that why Zach would like to establish Edge Impulse in several years ago, because Edge Impulse is also a tool platform for Edge AI. So what's the story and what the problems they would like to solve and what they have seen? So he gave us very interesting answers. Please see the video clips, please.
Thank you, Hagen. Hey, great to be here with Advantech at COMPUTEX. Always an awesome show. Sorry I couldn't be there in person this year, but next year. Yeah, the story of Edge Impulse started almost a decade ago. When I was at ARM, we were beginning to do the very early machine learning on silicon work. What does it mean to take a machine learning model and go run it on a CPU or an embedded microcontroller? How does that work? And We did a bunch of open source work with our team. We had some of the brightest people in the world working with Google and others. And you know what? It was just too hard. The tools were so manual and difficult. There was like literally one guy at Google who could train models. And there were 3 models. One of them was MNIST. And everyone else just ran the example running on a microcontroller. It was just taking dummy files from Flash and saying, hey, here's a shoe, here's a dress, right? Completely useless demos and almost impossible to use, almost impossible to train. So that was the state of machine learning tooling back almost a decade ago when we began, and we started building the TinyML foundation and the TinyML movement around that. My reaction as an industrial software guy, right, was that, oh my God, this is so unusable. How are we ever going to get industrial people to go use their data to solve real problems with AI? It's nearly impossible. So we felt that there's this massive disconnect between the tools for machine learning and then industry that needs to actually use machine learning for something. And so Edge Impulse was born from that gap. Jan and I, we got together and thought, well, maybe we're the right people to solve this problem because we're industrial software people, right? We care about amazing software developer tools. We care about industrial engineers and people across all industries. How do they use these tools to solve their own problems? And so we created Edge Impulse around the vision of democratization of machine learning and AI across all industries. And in particular, how do we enable the developers and the engineers to go build things themselves and deploy it to any type of silicon? And so that's how we started. The challenge that industries have are really twofold. There's threefold, right? One, where do you get the data? How do you get the data? How do you organize the data and curate it and make it useful for machine learning? Machine learning data is very different than IoT data, right? It's not just measuring temperature once every 10 minutes or GPS location. You really have to measure very high quality signals, and you have to know exactly what happened at that time. Did the machine break right here? Do we get the full bandwidth of all the signals that happen? Audio, video, sensors, all at that time. Do we have a very high quality label, right? Like these are the things we have to take care of. So one of the first problems that Edge Impulse solves is data collection. How do we instrument those devices in the field? Because you need the real data, right? This isn't something you get from the internet to solve a pipe leakage problem or a manufacturing safety problem, right? This is stuff you have to get from your real environments, from the real sensors. So we instrument those devices, and then we enable this mass scale of data collection across these industries into very well-formed data sets. So that's the challenge number one. Challenge number two then is, how do you figure out the right problems to solve? So once we have some of that data, we have maybe a thesis of what that data can be used for. How do you go iterate? How do you have your engineers go and start to first identify those first problems, use that data to solve the problem, explore all the different model architectures that could be useful, and then go and test it out in POCs to begin with? So that's the second thing that Edge Impulse was built for, is that we're built for very rapid prototyping. How do we solve a problem in a few hours or a few days? How do we get it to production in weeks or a few months at maximum? That kind of scale of innovation, because before it took 18 months to get an AI solution to market. That's way too slow. So that kind of rapid innovation using custom data, right? Training custom models every single time is really important. And then the final thing is deployment. How do we get then that algorithm that we've developed onto something real, onto real hardware? It's the third major, really important problem, because if you don't get that model into real use, you don't know whether it actually works, and you don't know how to collect more data. So what we recommend is that you get something to real use as fast as possible, a matter of days or weeks. And then you use that to start collecting more data, because you only understand what data you're missing when you have a model in use where you see that, oh, this works, this doesn't work, great, let's collect more data. 99% of the work we do in machine learning is data. So those are the three major challenges that we went to solve. And then there's a couple examples, great examples of of applications that we've seen solved like this using the tools. One is actually at Advantech. Funny enough, you guys probably don't know about this, but some years ago, we worked with Advantech manufacturing on one of the manufacturing lines for gateways. And one of the problems that the manufacturing managers had was safety monitoring, safety inspection. Are the workers being safe, right? Are they doing things the right way, that there's not danger, which could cause massive problems for the worker, but also for the whole manufacturing line efficiency. So we went and installed overhead cameras using Advantech cameras and gateways. And we designed models to go and look at when there are safety problems on lines, right? When is somebody reaching their hand too far, right? Or doing the wrong thing. And by doing that and enabling this kind of automated inspection, we saved 15% in manager efficiency. So 15% of the manager's time was saved by not having to go and watch these safety issues all the time manually. It's a super interesting use case in manufacturing. Another great example is power line monitoring and energy grids. So as you know, in California, where I've lived for almost 10 years, we have a lot of problems with forest fires. Many of those fires, like the recent fire in LA, they're caused by power lines going down and high winds, creating sparks. And it's hard for power companies to identify exactly where that happened. Which line, right? Where do they need to go? What happened? Did a tree hit it? Did it fall down? And so we worked with a company in Europe that creates those insulators for power lines and the sensors that they put under the insulators. And those are usually dumb sensors. Using Edge Impulse, they were able to, in the laboratory, reproduce all of these things that can happen and train machine learning models that run right on that device, actually a microcontroller-based cellular connected device, in order to detect immediately when something happens and which power pole does it happen at. And that signal message goes off to the operator and they can go fix the problem. So really amazing what machine learning can do when you start applying it to very specific problems. And then I want to stress the importance of hardware here, right? A lot of this that we're enabling in the embedded industry, in real industries, it does matter what we can do with hardware. So that example I gave on the power lines, those devices have to work for 20 years on one battery. That requires very low power connected microcontrollers, right? So we have to be able to fit machine learning into that device. The vision monitoring safety system I talked about, that takes multi-core CPUs, right? So we need the right kind of CPUs on a camera platform that's very easy to install. So something like the iCam from Advantech, right? We need something like that in order to install that vision model. And then in the future, right, where the future of this is all going is that we're going to be able to apply more and more cascading model architectures where we can go do things like object detection for certain types of things we're interested in, and then throw them into very large models. So think multimodal LLMs like vision language models. We just did a demonstration at Embedded World on a Dragonwing IQ9, where for the first time we can run an 8 billion parameter VLM and start to do like very advanced processing of what's happening in an image, right? What's going on? What's the context? Things that you'd never be able to do with traditional discrete models. So that's kind of where the future of machine learning is going, is combinations of discrete and Gen AI models, but then we need even more powerful hardware to do that.
Zach gave us a very comprehensive vision for how Edge Impulse see this world and what problems they're solving. So everything is the problem around the data. And also he mentioned the importance of future of the hardware, heterogeneous hardware. We need less power consumption hardware, but with high efficiency. So Richard, how do we see the challenges for edge to the intelligent to the edge, and what's our Wise Edge equips what kind of capabilities to face these challenges?
Okay, actually we share the similar idea or prospect, just like Zach mentioned, because because nowadays the front-end devices, especially edge devices, most of them are ARM embedded systems. Most currently nowadays AI experts, so-called AI experts, they might be civil engineer or environmental analyst. They are not quite familiar with those kind of systems. Usually they develop their models on desktop computer with NVIDIA GPUs, but they will face difficulties to migrate their built model from desktop computer to edge devices. So we prepare a lot of tools, such as the primary tool we provide is containers. So we can migrate from the developers or end users. After they develop their applications, they can deploy their applications on different platforms, no matter the chipset is a Qualcomm or NXP. That is Advantech provide. And the second thing is, just like what I said, we provide a bunch of APIs, and most of them are for IoT management, IoT data management. What does it mean, IoT data management? Because in the past, the traditional IoT platform, they only focus on data collecting. But just like Zach said, high quality data is a key to build a feasible, reliable AI model. So we pre-process all the data on our platform and make sure all the data are ready to fit into AI modeling system, just like the Edge Impulse. And after the trained model can be deployed and push to the front devices. So the entire ecosystem we build is to collecting data, pre-process, AI model building, and then deploy. So that is the entire ecosystem we provide.
Right now you can see how we prepare a platform from one stage and Edge Impulse and build out a circle to help the Edge AI to the real. So let's listen to Zach. He's sharing how do he see the future of AI at the edge. Please see the video.
Yeah, so Hank, really good question. Everybody's thinking about LLMs and what's happening with Gen AI, but really in our world, right, of industrial systems, when we think about LLMs and Gen AI, I think we always have to think about hybrid systems, right? We're never going to be dealing with just LLMs. We're not going to just throw industrial data directly into this massive model and something will magically happen. Probably we'll get a lot of low quality, very difficult to deal with responses, or very expensive models, right? Operating those massive models in the cloud is going to cost us a fortune if we did that at scale. Also, it's not going to be private, right? All that data is going to go to somebody's large model in the cloud. Industries won't have that. So there's a lot of problems with the consumer model of thinking about LLMs. So we should stop thinking about LLMs that way. Where we're seeing a lot of really interesting use cases for LLMs, first and foremost, is in the engineering process. So not necessarily first in deploying LLMs right at the edge to do something. Instead, we're seeing massive usability of LLMs in making the data collection and labeling process easier and better. Huge problem, right? I talked about that data challenge, right? We need to get all this data. In most industries, the data doesn't exist. We have to get it. And then we have to label it, which is difficult, right? To do that by hand. So we've already built into Edge Impulse the support for chaining of LLMs so that you can use those LLMs to go and do auto labeling processes. You can actually do like prompt engineering with this kind of cascade of prompts. So you can say, you know, find the people from the image. Great, now find the hard hats, but only this type of hard hat. And you can start to have like very accurate labeling using these really large models. The other thing that we're finding very useful is synthetic data generation. So we built in the integration of LLMs into the Edge Impulse platform, so you can actually use those LLMs to go and create new data once you've started your data set. So we don't typically see this for replacing all data collection. Usually you still need real world data, but you can augment those data sets by using synthetic data generation. And we can do that for computer vision if we need more images of a certain type, or different angles of an image, or different lighting environments, etc. Or for audio, we can do amazing things, generating human speech keywords for keyword spotting models. We can generate sounds. Think about a car crashing and we want to detect that, this kind of glass breaking and metal sounds and tires screeching. We can build those sounds synthetically. And then there is a lot happening with the deployment of these models towards the edge. And I think that's also very interesting. So once we use LLM for kind of helping the engineering process, that will make better discrete models to begin with. Once we have a discrete model, that happens very high performance, very efficiently. We can go capture the thing we're interested in, right? So for example, in automobile analytics, if we're looking at cars and car analytics in a parking lot, for example, the first thing we need to do is capture the car. And we only want to capture the car once, right? We don't want 50 images of the same car from different angles. We want one really good image. And that's where discrete object detectors are really good. So let's use the discrete models. They're high performance, they're efficient. They'll get us that one image. And then we can cascade into a Gen AI model to do further, very deep analytics. That's slow, right? That might take seconds of time, maybe even minutes, depending on the hardware. We can't do that for every frame, right? So let's be very careful how much we use that. And once we apply like a vision language model in the right way, we can go do really interesting things. So what we demonstrated at Embedded World, we deployed a vision language model on the Dragonwing IQ9 series, and that we were able to do very detailed vehicle analytics. What's the make, the model, the color, the license plate? Is there something written on the side of the van, right? Like somebody's plumbing company. What kind of wheels does the car have? Is there a roof rack? Is there damage to the car? You name it. Very, very detailed, interesting things you can extract from this VLM. And then when things get more complicated, when you start getting past, cascading to things like VLMs or using very small language models to do better human speech interfaces, that's coming. Then you start to get into agentic models, so networks of models that work together. And the trend we're seeing happen right now is that those are going into AI appliances. So we're seeing very interesting work on AI appliances from Qualcomm, where we have towards 1,000 TOPS and beyond. And that lets us deploy very large models together with things like RAG, where we can store a lot of documents. We can do multiple things in collaboration. And I see that as like a hybrid model too, where we can run object detectors at the cameras right in the field, like on an iCam. And then we can move an image to an AI appliance for more complicated processing. So I think we're gonna have a very interesting future where these things come together as tools, and Edge Impulse will be there as a development platform to go make use of those.
It's very exciting. We see many possibilities in the future to bring the intelligence at the edge. So, Richard, what's our preparation and what's our reaction to this future? How do you see?
Okay, actually, Zach brings two very important points. One is a hybrid AI, and the second is how to use such as the physical model to generate more data for training. That's very two important points. And how Wise Age liberates these 2 points. The first is I can explain the Gen AI first. For the we can use this slide. In Wise Age, we are not just link our kernel to the Edge Impulse, this kind of model. We also link to connect it to the such as the NVIDIA Omniverse or Azure Digital Twin. So we can use a physical model to generate more data, to simulate more data for further training. That is the first point, to speed up the AI model, to prepare the feasible AI model and transfer or push them to the front end. And the second thing is how to use LLM or the large language model or the Agentic AI with the Edge Sync or Wise Edge system. We can move to the next slide. I can give you a. Sorry, we do not prepare that one. The Edge Sync, we are going to prepare a lot of MCPs. So in the future, we hope we can control the entire, such as the factory, or read or analyze the IoT data, all by voice or language interactive without the traditional graphic user interface. I believe Microsoft CEO a few months ago, he also mentioned that maybe in the future, the SaaS service will be obsolete. That means, just like about 20, 30 years ago, when we want to book a theater, want to buy a ticket, we just have a phone call to a booth, and they will help us to order the tickets. In the future, and nowadays, we just use a graphic user interface on website to book out the movie theater tickets. But in the future, I think with the Agentic AI, we can do that all by voice interaction.
Thank you, Richard. So for Advantech, we commit to this future, and we believe that it will coming very soon. With Edge Impulse and Wise Edge, we would like to help all our customers and all the developers to jump into a new era. So thanks again for Richard and Zach. So if you have any question, please don't hesitate to reach to us. Advantech and Edge Impulse will provide new solutions and for all the developers. Thank you very much. Thank you.
Hey, thank you for having me, and I hope that everyone goes straight to edgeimpulse.com, sign up for your free account, and get started working on your own machine learning models using Advantech hardware. Thank you.
Thank you for joining.